All right, so the first thing we're going to do is we are going to do a u substitution on this, and I am going to let u be that natural log of x. And as you see as we progress through here, why this is going to work. We're going to let u be the natural log of x. All right, now when I take the derivative of both sides, I'm going to have a du. Taking the derivative here, we'll have a 1 over x dx. I want to go ahead and solve all the way down for dx, so I'm going to multiply both sides by x. So I'll have an x du is equal to dx. All right, now what that's going to allow us to do is our x's are going to cross out. Now, when I go to this next line here, I am going to remove those limits of integration. These are the limits of integration for x, and I am going to start manipulating this integral so that I am now going to be in terms of u. The natural log of x we let be u, so I'm going to have a u there on top. It'll still have that x right there momentarily. All right, the dx I'm going to substitute for x du, which now allows the two x's to cross out. All right, so letting that u be the natural log of x and seeing what its derivative is allows for that to cross out. I now have an integral that is all in terms of u, so the integral of u du. So I don't want to have any limits of integration here. I mean, I can change these limits of integration for x into limits of integration for u, but this is a straightforward short one. There's really no reason to do that. So I'm just going to remove those limits of integration because they would not match for an equation that is written in terms of u. So if I go ahead and integrate this here, we're just going to have a nice little integration of a 1/2 u squared. All right, whether or not you put the plus c on here, it's not going to make any difference. I'm now going to go to replacing u to what it equals. So I'm going to have a 1/2 natural log of x to the second power. I can now add back in my limits of integration for x because now I have an equation in terms of x. All right, going through here and substituting in, putting that e in there, I'm going to have a 1/2 times the natural log of e to the second power, and then minus, plugging in that 1, I'm going to have a 1/2 natural log of 1 raised to the second power. All right, so this is going to be 1 times 1/2 will give me a 1/2 here. All right, natural log of 1, 0, 0 squared times 1/2 is going to give me a 0 here. Overall answer here then to this limit is a 1/2. Definitely, though, thanks for watching. This pretty much is, like I said, a straightforward u substitution. You've just got to realize what's going to happen when you let u be natural log of x. You get that derivative of 1 over x, which lets those x's fall out. All right, and it really is kind of important. These are limits of integration for x because your original equation is written in terms of x. When I am at this point right here, I now have an equation written in terms of u, so I don't want to put the 1 and the e right here. They are limits of integration for x. This is now in terms of u. All right, but once I integrate and then I put my x back in, now I have an equation back in terms of x. So then I can put those limits of integration for x back in. And then, like I said, sometimes, depending, especially if it's a much harder, much more complicated integral, we will change the limits of integration from x to limits of integration for u, and then work it out in terms of that, and then you don't have to plug in the original, what you set u to be. All right, but this one was short enough, there was no reason to do that. So definitely thanks for watching. If the videos are helping, please share with your friends so they can benefit too. And don't forget to subscribe to the channel. Thanks.